In this video, we are going to talk about the elasticity of demand. So in the textbook, they give a different formula than this, but this is the formula that you will be given on the exam and that you're expected to use. So E of P stands for the elasticity, and we find it by taking negative P times F prime of P, so the derivative at P, divided by F of P. Okay, so E of P is the elasticity of demand, F of P is the demand function, and P is the price of the product. And sometimes instead of P, they might have everything in terms of X, but it would be the same idea. X would be the price, and then you would have F of X and E of X instead of P. So elasticity of demand is a measure of how demand reacts to price changes. For the formula, it's normalized, which means the particular prices and quantities don't matter and everything is treated as a percent change. So when we find E of P, it represents the percent change. Just keep that in mind when we're interpreting these. And so E stands for the elasticity of demand, and we have three cases. We always compare our E of P value to 1, and if E is less than 1, we say the demand is inelastic, which means if we raised prices, revenue would still increase. If E is greater than 1, we say the demand is elastic, and that means raising prices decreases revenue. And if E equals 1, we say the demand is unitary. And when this occurs, it's giving you the maximum revenue. So whatever that P value is, it gives us the maximum revenue. And percentage change in demand is equal to the percentage change in price. So anytime we get 1, we're saying the percentage change in demand is the exact same as the percentage change in the price. So it's really easy usually to tell how demand affects the prices. Like if you raise the demand, the price for the item generally goes down. Sorry, if you raise if the demand is, if there's a high demand, the price usually goes up. And if there's a low demand or the demand is decreasing, the price usually goes down. But the question often is what happens to the overall revenue? And that's what the elasticity of demand helps us figure out, is what is happening to the actual revenue, not just the price of the item, but how much we're making off of selling these items. So just as an example of inelastic and elastic goods, luxury goods and the price of certain foods and beverages are generally elastic. So for example, the change in the price of a luxury car can cause the change in the quantity demanded. But things like tobacco and prescription drugs are an example of inelastic goods. For example, the change in the cost of prescription drug usually does not change the demand, since customers still need that drug. And generally with tobacco, since people are addicted to smoking or chewing, even if the price goes up, the demand is still the same. So we are going to look at a few examples. Again, anytime we're finding E of P, we are going to use this formula, and this formula will be given on the exam, so you do not have to have it memorized. Okay, so this just says find E of P if F of P equals 12,000 minus 10 P squared. So we need F of P, which we have. We are just going to plug in our P, and then I need F prime of P. So I'm going to find that on the side. Make sure you label that so we know, so I know what it is when you're plugging in the formula. So the derivative of 12,000 is 0. So you can write it or you don't have to. And then the negative 10P squared, I would take the negative 10 and multiply by 2, which is 20. And then I would have P, and then I would subtract 1 from the exponent. So this derivative is just negative 20 P to the first, or P. And then for E of P, the formula would be negative P times the F prime of P, which is negative 20P, over F of P which it should be always given in these problems, which is 12,000 in this case, minus 10p squared. And then if you can simplify the numerator, you should. So negative p times negative 20p is 20p squared. And then the denominator is not going to change. So this is the equation for the elasticity of demand. B says determine if the demand is elastic, inelastic, or unitary at p equals 10, and interpret what E of p means. So in this case, I am just going to plug in 10 for p into my elastic equation. And then we're going to simplify this. So if you multiply out the numerator, you get 2,000. And then for the denominator, I would have 12,000 minus 10 times 10 squared is 1,000. And this gives me, if I simplify it, approximately 0.18. And so this, remember, we always compare it when we're talking about elastic or inelastic, we compare it to 1. So I'm really using this idea to see if it's less than 1, greater than 1, or equal to 1 to figure out if it's inelastic, elastic, or unitary. So 0.18 is less than 1. And so we know that if the price is $10, okay, and price would always be in terms of dollar, our demand is inelastic. Okay, because if you have to give a reason, E of 10 is less than 1. So what this means is that if we increase our price, it will still lead to an increase in revenue. So you'll often be asked if raising prices will increase or decrease revenue. And if our E of P is less than 1, then increasing prices still leads to an increase in revenue. So increasing prices doesn't change the demand enough that it would change the revenue. So let's look at one more example. Currently, 1,800 people ride in a commuter train each day and pay $4 for a ticket. The number of people X, which is the demand, willing to ride the train at price P is X equals 600 times the quantity 5 minus the square root of P. The railroad would like to increase its revenue. Should the price of the ticket be raised or lowered? So anytime we're trying to figure out if it's raised or lowered, and we're given kind of our demand function, we need to find E of P, and we need to figure out if E of P is less than or greater than 1. In this problem, instead of F, they're using X for the demand. So our normal like F of P in this case is just equal to X, or technically X of P. But this is the demand function. And that will happen in a few problems. Instead of using F as their function, they're going to use X. And so we, remember, are using our formula again from the page before, and you will be given this formula on the formula sheet. So this is my formula. So in this case, instead of F of P and F prime of P, it's actually negative P times X prime over X. Okay, or you could put X of P, it's the same idea. So we're actually using this formula here so that it matches the notation in the problem. So we need the derivative of our demand function of X. So in this case, I guess before we actually take the derivative, to make it a little bit easier and not have to use product rule, I'm going to distribute the 600. So if you don't distribute the 600, then you have to use product rule because you're multiplying two functions. But in order to make it a little bit easier and faster, I would distribute the 600. So 600 times 5 is 3,000. And 600 times negative square root of P is 600 times the square root of P. I'm going to change it to P to the 1/2, since we need to change our square roots to 1/2 before we take the derivative. So now when I take the derivative of 3,000 is 0. So I'm going to have negative 600 times the exponent of 1/2. And then I'm going to take 1/2 and subtract 1 to get the new exponent. So the derivative becomes negative 300 P to the negative 1/2. So now I'm going to plug it into my formula. So E of P is equal to negative P times what X is, or sorry, what X prime is, which is this negative 300 P to the negative 1/2, all over X. And it doesn't matter which one you use, I'll just use the original one they gave us. 600 times the quantity 5 minus the square root of P. So this is my E of P equation. To simplify it a little bit, I can multiply my numerator. So I would get negative P times negative 300. So a negative times a negative is a positive. And then the P times P to the negative 1/2. This is a 1 if we don't write it. So we add our exponents. So 1 plus negative 1/2 is just 1/2. And the one other thing I could do to simplify is the 300 and the 600. I could divide those. So I would get P to the 1/2 in the numerator, and 300 over 600 reduces to a 2 in the denominator, because 600 divided by 300 is 2, but it goes wherever the bigger number is. And so you could leave it like that, or you could distribute the 2, and you would get 10 minus 2P to the 1/2. So then I'm going to find if the price should be raised or lowered. So I have to pay attention to what the price currently is. And so they said currently 800 people ride a commuter train and the price is $4. So I'm going to plug in $4 into my function. So I have 4 to the 1/2, which again is the same thing as the square root of 4. You can leave it as an exponent or you can change it to a square root. And then I have 2 times 5 minus, again, P to the 1/2 the same as the square root of 4. So that gives me 2 over 2 times 5 minus 2. And so the 2's, well, I have 2 over, you could either cancel the 2's and make them a 1, or you can do 5 minus 2 is 3. 3 times 2 is 6. 2 over 6 is 1/3, or if I think about it, 0.333 repeating. So that is my E of P, and then I'm going to compare that to 1. So again, this is less than 1. So because it's less than 1, again, it's inelastic. And anytime it's inelastic, it means that a small increase in price will increase revenue. So the question said, should the price of the ticket be raised or lower? And we would say raised because it would still increase our revenue, and that's our ultimate goal. So we could still raise our price a little bit and still increase our revenue. If our E was greater than 1, then it would be elastic, and we wouldn't want to raise our price. We would actually want to lower our price because that would result in increased revenue. So again, the formula is given to you, but you do need to know these 3 things. You need to know that if E is less than 1, it's inelastic and raising prices increases revenue. If E is greater than 1, it's elastic and raising prices decreases revenue. And if E equals 1, it's unitary. It gives us the maximum revenue. So that's really what we would want for our price. If you have any questions, let me know.